All right then, let's get started. Thank you everyone for joining our data engineer interviewing series, focusing on Python, SQL, and data modeling questions. Glad to have everyone here with us today. I'll introduce our speaker, Anju. So Anju Mercian, she graduated from Syracuse University New York with a master's degree in computer engineering. And her previous work experience includes working at ETL for 5 years as infrastructure engineer, at VMware as a project manager, at Intuitive Surgical as a business system analyst, and Omdana as a platform engineer. She is currently a data engineering consultant at Meta Facebook, and you can read more on her Medium blog, medium.com / @Anju _Mercian. So Anju, I'll hand over the microphone to you.
Thank you, Eliza. And thank you for everybody that's joined. So today we are going to talk about, let me share my screen before I go ahead. So today is going to be our final day of our data engineering interview series. Actually, there's so much that's going that is you to study and so much to do, which I know I wouldn't have been able to do justice with only the four sessions, and there's a lot more to go in, and a lot more work that we need to do individually, and also like maybe if I get more sessions, I'll do that too. But in today's sessions, I'm going to focus on Python. So if you've attended my SQL session and you're here for the Python, so in SQL also it was like a cheat sheet, and for Python also today it's going to be a cheat sheet. What I'm planning or my vision is to provide a cheat sheet of all the commands and all the all the important libraries that usually get asked in interviews. Usually what they focus on. So this will be something like when you're preparing for your interviews. I would like this to be like a cheat sheet where you go and say, okay, I know this, I know that, kind of run through your head and say, okay, these are some things I've already touched base on, these are some things I've worked on, I kind of know all this. So like when you touch on it, that's something for me also is important. Like when I go over those, do I know this? Okay, do I know where I put this on? So that's what my vision is with the session today, because Python is huge. There's a lot we can do. There's a lot we can learn. We can have an entire course session. And so even actually when I was preparing the slides, I was like, oh, maybe I need to have another session for Pandas alone, because that's so much detail that I would like to share. Maybe I will have one in the future with the help of Women Who Code. I can have another one. So that's what I wanted to start off by saying, that it's mostly like a cheat sheet. And if you do have any further questions, please do contact me on Slack or Eliza on Slack, and we can discuss further. Also, I do write blogs and articles to supplement these, or also they can be standalone. I've already sent one to Women Who Code, which they'll start publishing in May for SQL, and I'll have more coming for data modeling and Python, which could hopefully help everybody, including me too. So this is like my personal cheat sheet too. So, okay, so let's get started. Python for data engineering. So whenever you see the job description for data engineer, they'll always say proficient in one of these languages, and they'll say Java, Scala, and Python, or Python. Why do they say that? Because there are data engineering tools, data science tools, ML tools that are built on Java and Scala, but Python is currently the most widely used. There are a few reasons why Python is used. One is like it's a dynamically typed language, and it is actually not as fast as Java and Scala. So, but still, it's widely used in almost many companies because they have a very good community. Python has a very good community, and they keep building anything for machine learning. They build easy libraries like Keras and TensorFlow that can be used for complex mathematical operations, right? If you're an ML engineer, you know how much TensorFlow and Keras has been useful to you, and like whipping up a project really soon. So that's how Python became really famous for anything related to data. And also the libraries are really good. And also one more advantage is compared to Java and Scala, this is an interpreter language. So if you want to do some coding, you can immediately go to an idle and get that, write the code out and run it. So if you can immediately see an error, instead of having to take the whole code and put it through a compiler and then get your answers and get seeing your errors. In Python, you can immediately run the code and you'll immediately know where your issues are, errors are. They have very good error feedback system. They have very good community that support you, so that's the reason why. And there are so many tools already built on Python. Even though Java and Scala, like Scala is like more functional programming is there, but if as a data engineer, if you go in and you're ready to open up and work on Python language and give an interview, you can interview well in Python, you're good. And there are so many big data tools that are already implemented with PyTorch, PySpark, Seaborn, Matplotlib. These Seaborn and Matplotlib are graph. They have very good graphs. I love Seaborn, using Seaborn for to showcase any graphs, like bar graphs. They have lots of wonderful graphs. They have that, the visualization is really good. TensorFlow, Scikit-learn is all ML libraries. Numpy is a very efficient scientific computing library. And then Pandas. Pandas is something we'll touch on today because many of our interviews, they'll have Pandas questions. So basically, whatever you do on SQL, you can actually completely transfer that to Pandas and showcase it on Pandas. We'll go over 3 questions. Where we'll use Pandas libraries to go over those questions and get so you can do the same thing for SQL and you can do the same thing on Pandas too. So one thing about the Pandas is, and I don't know how, the way they ask Python in so many data engineering interviews is very different. In some interviews, they ask the basic Python language, like some of the commands I'll go over. Sometimes they ask questions on Pandas related, data frames related, Pandas related. So knowing both will be important, and that's why I will I have made sure that in this presentation I cover both the basic libraries of Python that will be very helpful, and the Pandas libraries that will be very helpful to know. And all the questions that I've chosen are all based on Pandas libraries, because the Python, general Python based questions are already found on LeetCode, and it is kind of based on software engineering interview questions like reverse a string, reverse a list, reverse a linked list. The questions for data engineering interviews in some companies, except Google, I think Google is the only company that I've heard so far that do that. For a data engineer, they do the same as software engineer. So you'll have to know all what software engineers knows, like data dynamic programming, graphs, and trees. But most of the other companies, they only go with the basic understanding of the language. If you know, like reverse a string, reverse a linked list, iterating through a list, and all of those questions, LeetCode questions, they are maybe like easy and medium LeetCode questions. Whereas for Google, you need to know a little bit more of hard, like that. So that's why I'm not touching it. I'm just going to focus on the commands that will be important, and for Pandas, we'll go over the questions by the end of this presentation. If you have any questions, please feel free to ask on chat or Q&A. Q&A will be better, I think, and I will go over them. One thing is, I don't know how many people are beginners and intermediate and well-known in Python, but I don't think this is mainly meant for beginners, because this is not like a Python tutorial. That's what I wanted to mention again. It's not a Python tutorial. I'll just go over the important the libraries. Hopefully this will be like for an intermediate session. But I know Women Who Code Python has a lot of other Python series that can help beginners also. Okay. So how is Python used for data engineering? So Python is mostly used like for a data engineer. Like, so you're doing a day-to-day data engineer job. How is Python useful to you? Usually most of our analytic stuff as a data engineer, you do in SQL. you're trying to, you're going to query the database, you're going to model the database, everything in SQL. Where does Python come? Where does any of these higher level languages come is actually in the automating it, getting a SQL to getting a SQL to and from a code cloud base, or automating your pipelines to actually create tables. All of that behind the scenes that use tools like Apache Airflow, Apache Spark. That's where Python is used. Python is not used as a day-to-day language for a SQL. Like as a data engineer, day-to-day I use SQL. And only when I'm building pipelines, I use Python. Usually I use Python to automate my pipelines. And that's where many data engineers will be using a Python language, or Java, Scala, any of those higher level languages. Python comes in all stages of your data management process, in data ingestion, your data acquisition, data manipulation, and building ETL pipelines. Data ingestion is when you're taking your data in from the cloud or anywhere else. You're trying to ingest data from anywhere. Data acquisition is trying to find out where the data is coming from, like an API. If the data is coming from an API, then that's what is data acquisition. Data manipulation is like you can use manipulation SQL, but since Python has a wonderful tool library called Pandas, we can do the same data manipulation, like in the sense merging tables, sorting tables, deleting, slicing tables and creating a different view. All this also can be done using Python because of a library called Pandas. And then building ETL and ELT pipelines, and that's what I use as a data engineer for building the pipelines, is when I use Python to automate data flow, to run my SQL commands automatically, behind the scenes. Every night I want to fill in some of my tables, I'll use the Python code through an Apache Airflow orchestration, and orchestrate it to run every night at midnight. Make sure that all my tables are filled with the upstream data on this particular day, by partitioning on the date. So if by today's date, I want all the upstream pipelines to fill my pipeline and make sure it's all up to date. That's usually done in Python for me. So let's start with the Python commands that are useful. So or libraries. These are like mostly libraries. So you must have a good understanding of list and list comprehension, okay? Because that's actually widely used. They'll have a lot of questions in Python interviews based off list. You have to for loop list, because you can create your your for loop in one sentence, like one line. Why this is important? Doing this is important because most of the time in your technical interview round for a data engineer, you must be able to solve problems quick. Compared to a software engineer, right? Software engineer will have, like, in 1 hour they will have only 1 or 2 problems when you're interviewing. But for data engineer, you may have 10 questions that you need to solve in an hour. So the fastest way is you need to find out a way to do that. So for questions, list will be very useful. List, tuple, set, and dict. Okay, I'll go over them one by one, and the code base too. I've just written some more commands. Small commands, and I'll go over them one by one. So list is actually the most widely used. List comprehension, all of that is most widely used. They can grow and shrink as needed, so they're mutable. They are ordered. They have an order in list, and they're sortable. Okay, so list is usually used. Tuple is actually immutable. You can't change. Once it's in a tuple, it's fixed data. It's ordered, and they're faster than lists. Because they're ordered, they can't shrink and grow and everything, so they're faster. It allows duplicates because they are indexed. Lists also allow duplicates. What doesn't allow duplicates is set. So if they say find the duplicates, find the duplicates or delete the duplicates in this list of data, So actually you, in an interview question, if they ask that, what you can do is actually you can create that list as a set and then bring it back as a list. Okay, so they're giving you a list. Okay, 1, 2, 3, 4, 4, 4, 5, 5. Okay, now you have to take out 1, 4, and 1, 5 because they're duplicates. You just have to like create it as a set using the set keyword and putting the list into the set, and then outputting it into a list and printing that out. That will actually take out the duplicates. So that is one easy way of getting a duplicates removed from a list. So you don't have to go through the pain of having to like keep track of which one is duplicates. If it is not an ordered set, what do? You have to order it first, which takes a performance time. And then you have to like then go in and figure out if there's another of the same. So that again takes performance time. So you don't have to worry about that in a data engineering technical interview. You can use a set. And you can tell, hey, we can use set. I'll just use set and do. Knowing that will actually give you a point, kind of a thing. So you can use set and then dict. Dict usually comes as a key value pairs. They're an associative array and they're unordered. Okay. Now let's talk about dict and list a little bit in detail. Because I don't know if anybody wants to go much deeper into it, or if there are questions, please feel free to ask me any questions you want. So a dict is actually a dictionary. That's what we call a dict. So they are key value pairs. Okay, so I have to increase size.
Can you zoom in a little bit on the screen, Anju? Thank you.
Okay. How is this?
Perfect.
Okay, so a dict has a key value pair. So if you see here, this is a key and this is the value. So A is the key and 10 is the value. B is the key and 20 is the value, right? So you can use, you can use D of A and get that value, or you can also use the get function to get the value. Some things you can do with your dict. Using the key value pair, you can get your value, and then if you create a list of the dictionary items and get all the items that is there in the dictionary. The main thing I wanted to point out here was getting your for loop. Your for loop. So in my technical interview, there was a question on that. So they're given a dict. I had to go in and find a way to get all the item, the dict values, key values, into to print out the key values. So you need to do a lot of exercises where you're looping through a dictionary value, right? Like what is the key in a dictionary, and then print out the keys, then going over your the items. What are the items here? So item is both the key and value. That's something to remember. It's both the key and values. So you can do like for KV like this. For key value in dict items, you can only print out the keys, or you can print out the values. This has come in interviews before, like you having to use this syntax, not exactly this question, but having to use this syntax in interview questions has come before. So we got to like know this, like work on problems with this key value pairs. For dictionary and stuff like that. So that is about dictionaries, which is dict. So it's a key value pair. You can only get the values of the keys, or only the value. Or if you do d dot keys, you get only your key values. If you get d dot values, you get only your values. And then you can also so here, I have it. D dot keys gives you the keys, D dot values gives you values, and you can take out the D dot items and do have it as an array, like 1, 1, and it'll give you the first index and the value of the first column. So first key and the value of the first key. That's what this states. And it gives you the 20 value that is there, right? And yeah, and then if you have, you can pop out which the value of, so you can pop out the value of one of the keys. And if you do pop item, you can, you remove the last value. So here, if you do this, it'll remove this from the list. And so if you check again, okay, it would have removed that C value because it has popped that item, right? So those things are good to know, or good to remember. These are the functionalities, these are the libraries for dictionaries. And like d1.update. So you have two dictionaries, you want to update one with another, or you want to change one of the values and then update to another. This is how you do that. So you have an update command. So these are some of the functionalities you got to remember when attending interviews. So if you do them more than once, or have them in a sheet, and make sure you remember them. When you're doing problems, this will help you. All this, knowing how to manipulate a dictionary will help you. Sometimes they may also ask you a question and give you the answer for it, and ask you if the answer is correct, right? Like a multiple choice question. And so you need to be able to quickly say, oh, okay, so if they're iterating through the dictionary, how are we getting this value? How is this value being printed out? All that. Okay. So that is good to remember. What is a list? List is a list, as the name goes. It's a list, and lists are usually in. So one thing I wanted to point out is in dictionaries. How do you create a dictionary? There are two ways to create a dictionary. One in these curly braces and have the key value pair in them, and or you can also use a constructor, dict constructor, and have them here as a list. So inside dict constructor, you're creating the list of key value pairs. For a list, we should remember they are in the square brackets because a tuple is in the parentheses. And list is in the square brackets. That's a difference, like in command lines, that's a difference between list and a tuple. I'm sorry for the beginner, if it is too beginning for you guys, but I just wanted to mention some of the stuff. So so this is how a list is created, and so if you want, sometimes you have a list of numbers. List comprehension, how do you create a list comprehension is you can have a list of numbers okay, x, oh, let me get that. I want to just write that down. I'll get it to you. But I'll get it to you in a for loop here. I think I had the for loop. Okay. I did not have it. Like in a list comprehension, you can create it as like in a for loop within a list comprehension. That will be helpful. But let's go over this and then come to the. And then the same thing with a set or a tuple. So if you have the set, a set is again in a curly braces or in a set constructor like this. That's how a set is. And so for a set, you need to know how to add. And also we should always remember between list, dict, and set, which is immutable, which is mutable. So list and dictionaries are all mutable. Tuple is not mutable, is immutable. Okay, we should know that. So how do you update? So one thing I'll do is I will send out this presentation together in the Slack channel for everybody to see. So I also have the sources linked where I have the sources that I use to learn. So you can go over those lists, because I don't know how much further I can go in this. I also do have a little more to finish and go into Pandas. These are all like basic beginner stuff to go over set and list. But if you do have any questions on set, list, dictionaries, please feel free to ask questions. Then knowing for and while loops. So you may think, oh, this is all easy, but I just like letting you know, because when in time of crunch in interviews, we sometimes forget our basic syntax is just in our mind thought process. Sometimes, and also sometimes when you have like once you pass the technical rounds and you're going into interviews with an actual person, or with the one-on-one interviews, they'll ask you some questions like, hey, what's the difference between for and while loop, and all those questions. So it's good to know what's the difference between for and while loop, what's the difference between the list and tuple. Why do you use set? Set is usually used to delete duplicates. So it can be used for many other things, but usually it's used for deleting duplicates. But most of the time we use lists. And why do you prefer for or while for a certain question or a certain program that you want to create? So knowing the difference between them is important. That's why I have this here. Okay, so now let's move on to some of the other functions. Lambda function. This is very, very important because Python, we use Lambda functions left, right, center, I'd say. We use a Lambda function a lot. What is a Lambda function? It's an anonymous function, a function without a name. It can take in as many arguments, but it'll return only one argument. It'll return only one argument, right? For example, here, if this is like a regular function, def function of x, return x x into 2, which will give you 3. For x is equal to 3, it gives you 6. The same thing you can do in lambda function, lambda x into 3, that'll give you the answer, but this doesn't have a name. The function doesn't have a name. Lambda functions are very, very useful in upcoming libraries, and lambda function is also very useful in for interviews and also for your day-to-day functions. Okay. With lambda functions, we have filter functions. This especially when you are working with Python and data, and you're doing the same thing as SQL for data, all of this comes to use. You can filter out. So if you want to filter out in this list, you want to filter out anything that any non-even numbers. So basically you only have to keep even numbers, and you need to delete all non-even numbers. Then you can filter it out with the lambda function like this, and then give your second argument. So how does the filter function work? You have the filter, you have the function, which you can actually also create a named function, but having a lambda one-line function is always easier to store that function in the memory. Why lambda function is preferred compared to a written function is because lambda wouldn't take up space in memory. It's in one line. It can interpret right away, but if you create a named function, it will be stored in the stack memory of your memory, of your system memory, which you don't want. You want to use as much less memory as possible. So that's why we use something like a lambda function. So especially when you're just filtering out and you just need the filtered data, we can use lambda functions there. So here in this example, I only want even numbers. I won't take out all the odd numbers. So that's why I'm using lambda function. So if it's divisible by 2, then keep it. If it's not divided by 2, then don't keep it. So that's how list comprehension functions can be. That's filter. So you can filter out the specific. You can focus on the specific values in an iterable to use the filter function. That's one filter function. Then map function is important. When you want to modify every value in an iterable, you use the map function. So we have a list here, and you want the power, the squared of the list, for example. That's so here why we are converting the map function to list is because when you just do the map, it will just give you the type. It'll only so the map function only point to the address of where and the memory where it is stored. And list is what the list function is what translates that address pointer to back, takes the details from that address and puts it out into a console or into a shell. Okay, so that's what it does. So if you just do filter, it'll only give you the address of the address location of where that's with both filter, map and apply functions. It'll only give you the address if you just do that. You need to convert it into list to be able to grab the data within that address and print it out. That's why we use list. Now, if you ask me, can you use set or anything? No, none of those work. List is what works well. To get your information from the stored memory location to your console. Okay. So that's the same with map too, right? So you maps maps every value with the iterable. So what is every value with the function. So your iterable is actually the list comprehension, and the function is your lambda function. So here in this case, you want to convert all your contents in the list to the square root, and it does that here. That is map for you. Then you have an apply function. Apply function comes a lot handy when you're using Pandas. Apply function, all of these functions, apply, filter, map, lambda functions, they come in very handy when you're using Pandas data frame to work on in solving your problems. So you want to apply a function, a mean function to your data frame that you use apply. So apply applies whatever the function that you're calling it, the function to your iterable. So it just applies a particular function. So you take for example, you have a list of names, and you want all the names to make sure it's lower, it's in lower letters. Then you can apply a function to just convert everything into lower, all the strings to lower, using this apply function and the lambda function, and it'll convert it into lower. So that's what apply is, and comes in very handy in Pandas data frames. So Matt has a question. I wanted to ask how you think data engineering or programming in general will change with the advance of tools such as ChatGPT or GitHub Copilot. This is very interesting because we have been having these conversations about how GTP will take away our jobs or stuff like that. But in Medium, there's a blog that somebody had written on how he got, it's a very nice blog. I'll share the link to the blog on how he got ChatGPT to do some of his data engineering work. One thing what was interesting when I was reading the blog was he had to give specific instructions to ChatGPT to do it. So he had to be a very good, thorough data engineer to be able to direct ChatGPT to get his work done. So one thing is actually ChatGPT, from reading the article and reading many other articles, what I have understood so far is this will be a companion. ChatGPT or any other AI will be a companion for you and not replace you. But you still need to know the intricate details, how to run the cloud. You need to know the commands. You need to know what you should do, how the pipeline should be. You need the design, everything. As a human, you need to know to be able to direct that, to be able to direct ChatGPT to it, because he had to literally say, log into my S3 account. These are the credentials. Do this, to my SageMaker. Do this. To this. So you have to, only if you know how to do that, can you actually direct somebody to direct the AI to do that. So I think it'll be, but you don't have to sit and write the code for it. Like infrastructure as code, you have to write this one by one. It'll be the same code for everything that you do. which you can get help from like ChatGPT to write the code for you, but it will not replace you, at least right now. Maybe it'll start getting more intelligent, but at this stage where we are, humans are still needed. Humans are really very much needed. So I'll share that article. It is a very interesting article on how he got ChatGPT to do data engineering tasks. So I don't think we'll be replaced soon. But that's a very interesting question, because that's something when I was thinking, oh my God, ChatGPT is coming, what's going to happen to my job? But if you're really skilled, if you can all learn all the skills and you're really skilled, no other AI can replace you. That's right. Okay. So thank you, Matt, for your question. Okay, so let's go into other questions that will possibly be asked. One is a shallow copy versus deep copy. This is actually like a Python specific thing. What is shallow copy? What's deep copy? So you always, when you're working on data frames or when you're working on code, you would like, when you're like going to modify the code, you always like to take a copy. At least I would like to take a copy. And when you're doing any work, you always say, hey, copy this, right? Make sure you have your original copied somewhere, so that the original is not changed. So there are two ways to copy. One is shallow copies, which you just do as, which you just do as an equal to. Okay, so y is equal to this. Take this list of this. So what this does is basically it takes the address of those points, or the address location of these points, and then stores the address location to that. Stores the address location and the data to that. Okay, so it creates a new YS copy, but there is a pointer still between YS and XS. There's a pointer copy from YS to XS, and it creates another copy. So it will be kind of considered independent, but it's still dependent on YS because on XS, because when you change whatever is here, whenever you change in XS, whenever you change, so instead of 2, you're putting 20, it will change in YS. But if you're adding anything to XS, it won't change in YS. This is shallow copy. So it's not completely independent, but it's still kind of independent. You have a copy, but if you make any changes to your original copy, it will change even in your even the copy that you have kept aside, if you do a shallow copy. Now, deep copy is when not just the address location, but the address location, the content, the child of the content, everything is stored. That's deep copy. So if you make any changes to your original data, it won't change the copy. Okay, it is completely independent. So you've completely isolated your copy from any changes that you're going to do to your original. But in shallow copy, if you make any changes, so if you add anything new, it won't change. It won't change the original copy. But if you change the original, it will change it in the copy too. Hope you understood that. This may be a little difficult. I may not be able to show you also. Like deep copy is completely like making a different element, different memory location, different altogether compared to a shallow copy. And which is important to know is because when you're making copies, you should be careful, because if you change the original, suppose you do something to the original, if you lose your copy, right? We don't want to do that, especially when you're working on large sets of data. So you need to know the difference between shallow and deep copy. Okay, this will maybe like a theoretical question that they ask you. Next is, how is memory managed in Python? So if you know how Python's how memory is, I want to draw.io. Sorry, I should have taken out my draw. Wait, no. How do I draw? Okay, let me see if I can do it in shapes. Okay, so in shapes I'll do. So if you have a full set, okay? In you this consider this your whole memory. So when you consider this your whole memory, you have one, this is considered your stack, okay? This downstairs, this one is your stack. This is where when you create functions, anything, your functions, everything is stored in this memory, okay? Then you have one for predetermined tasks, okay? Like for Python, all the stuff that the Python has to do on its own. You bring in your libraries, bring in your preprocessor details, everything is here in this, okay? Preprocessor is here in your memory. Then there is something called a heap memory. This is where whenever you create variables and functions, variables, it gets stored in heap, and heap grows up, stack grows down, okay? And preprocessor is always stagnant, it's the same. So in your heap memory, so whenever you create any like x is equal to 0, right? You're initializing a variable, a is equal to 0, b is equal to 0, something like that, your sum is equal to 0. So that sum has to go and take some memory space and allocate this memory space, saying that, hey, okay, something is going to come and fill the space. I'm going to go create a space. So that goes and creates in the heap memory. So Python's memory will automatically allocate the memory. Then once the program is done, your function is done, whatever you're doing is done, Python will automatically go and delete those garbage collections in those memories. This garbage collection is very important. Sometimes you have the space, you've taken up the space, and if you don't let go of the space, in certain programming languages, you get error. It'll get memory out of memory errors. That's because you may have taken off space and not given it back. But Python, there is automatic garbage collection, which when you're no longer using, when the function is done or when the program is done, and when you're no longer using that memory, it will free up the space from the heap. Okay, which is one very good thing with memory, because even in C++, when you need to do garbage collection on your own. You need to go free up that thread. If you're using threads, you're creating threads or any multiprocessing stuff, you need to go and you need to make sure you free up that thread. But Python is really good in that one way, is it'll automatically go free up that memory. So this is very important for you to remember. Memory management. This I have a source here. Please make sure to read it. It's very beautiful. Anything in the realpython.com, I've been reading that up, and it's been very nice, a very good tutorial compared to many of the other tutorials out there. Real Python is a very good tutorial. So there is that's how memory is managed in Python. That can be a question. Then Python, how is Python's arguments passed? Okay, Python's argument is passed as is by reference. So there are two ways that references arguments will be passed. Arguments passed. It's like reference. It's passed by copy. Basically, it'll take that whole data itself, the value itself, and pass it when you're calling a function. Or it's passed by reference. By reference, in the sense, it only passes the address of that location and not the actual data in the location. So by default, Python argument passing is by reference. So what that means is, if a Python reference is changed, it reflects back to the calling function. Yeah, so both the new variable and the original variable will be ending up pointing to the same object, because so it won't create a whole another memory set for it, memory address for it. It's very memory conscious, memory management conscious. It will not, it won't allocate another space if it's actually just pointing to the same location. Okay, so that's how Python arguments are passed. Okay. So Python decorators are important, but actually I just wanted to put this in here, but I've never been questioned on this decorator. But it's good to know what Python decorators are. So a Python decorator is the implementation of a pattern that allows adding a behavior to a function or a class. Okay, so here in this to your argument. So for this function, decorated function, you want to add in you want to add something else above it. Like here, you want to add in the calling function name, which is the calling function, right? So here you're going to say, I want this particular detail on whenever I use this function, I want this particular detail. So you use it as a decorator. Okay, you create a function, you use it as a decorator so that this decorator falls on your function. Yeah, so that's what a decorator is. And I do have example of like here on your right. This is, so you have the a function that you want, and you're doing the lambda, you want to do the trace. So sometimes you're trying to find the trace. It's usually trace is actually is when you're trying to find out where the error happened, where the issue happened. You want to use trace to figure out where the issue happened. So this is one example where you're trying to trace which function called where. So you create a function to get me the trace of which function was called, so I know, hey, which function was exactly called, and what are the arguments, and what are the keyword arguments and everything. So that trace is what I'm trying to use with the decorator here. This actually inbuilt trace too, but this is like, if you really, because sometimes the inbuilt trace bugs, they are not very detailed. So this will help you try to find, use a decorator and find what is the calling function, where was function called, which was the calling function called. So see, this is how that trace is done. Okay, so that's like a decorator that you can use. You can use decorators in many ways. But that's something good to know. Then args and keyword args. Okay, I don't know. I'm not going to say that. So these two functions now. Without even these two, a function will run. But knowing why we have these args and k args is very important. So args allows you to pass desired arguments to the function. So you have one function, but you may have number of arguments that are going into the function, like here. Okay, so here I have this function. Okay, so I have demo star args. Okay, but this actually, when it's just if you did not have this star here, you would have only been able to pass one variable. Okay, you wouldn't be able to pass the Mercian here. Now, because you have this, okay, you can pass in any number of arguments. Even you can pass in more than 2 arguments, right? Like that. You can pass in more than 2 arguments and it will take it in. Right. So you don't have to define the number of arguments coming in when you use the star args. And what is KW args is keyword args. KW is nothing but keyword arguments. Okay, that suggests that you can have anything keyword based. What does that mean? Is that here there's a keyword here, so you have a keyword like name and you have a keyword location. It takes that in. Okay, so that comes in useful here. So if you have this, this is the function you have. Okay, and you are giving in args, so it takes in 3 args. But keyword args, if you see, you can pass it in any way, but here you have keywords first, second, and third. Here you're putting in third, second, and first, but it will output the exact numbers, exact over here. Like however this is displayed, it will take in the keyword exactly and assign it to that. So first gets assigned to 1, second gets assigned to 2. So you can have the keyword along with the arguments. That's why you have KW args. That's the difference between args and KW arg. Okay. So those are all Python language basics that are good to know and good to understand. If there's anything missing and you think it's important, please let me know. Okay, so there are many Python packages that are used for data engineering, ML, data science, and everything. And these are these are the few, like Cafe, PyTorch, Theano, TensorFlow, Keras, Pandas, Numpy, Matplotlib, and SciPy. Okay, I have other than Cafe, I think I've used PyTorch, I've used TensorFlow, I've used Keras and TensorFlow, I've used and PyTorch I've used mostly for machine learning. Numpy I've used even for Pandas. Numpy is very good scientific library. Anything anything that you want to do in Excel, you actually can do in Numpy, you know. That's a wonderful library. Matplotlib is a great graphing plotting library. And SciPy I have used a little bit. It's called Scientific Python, but I've used that for plotting and graphing. Most extensively used by data engineers would be Pandas and Numpy. Pandas is the go-to Python library for data analysis. We'll go over more commands of Python. And then Numpy is also used in conjunction with Python. If you want to take mean, you want to take average, mean, sum, all of these computations you want to do on your Python on your data, you use Numpy. Okay. So coming to Pandas. So Pandas, everything in Pandas is in a data frame. So data frame is the widely used data structure. There's data frame and series. Data frame, you have the whole table. You can create the whole SQL table kind of. It's actually comparable to a SQL query. So Pandas data frame is compared to a SQL table. You can have all of that whole data structure there in the data frame. This Pandas series is only the column. If you want to take a series, it only takes one column of a data frame. That's Pandas series. But data frame is what very widely used in Pandas. Okay. So data frame has data aligned in rows and columns, just like a SQL. Okay, you can hard code a data frame, or you can import it from CSV, TSV, Excel, from anywhere. You import it to Pandas. It's very very good. Even a pickle file, which you store it as a compressed file at the backend for Python, that can also be retrieved. I have used Pandas many times when I'm trying to take data from the internet and download data from the internet, use Pandas to convert it into a Pandas data frame with a SQL table, and then which is like SQL table, and use that to do some data analysis on the data, right? So this is how you have a Pandas data frame. This is the syntax: Pandas data frame. You have the data. Then if you have an indexing for that, you can have the index. Then what are the different columns you have? If you're creating this database, what are the different columns? What are the types of columns? Whether you want to copy it or not, you know, using it for copying data, if any. So that's the Pandas data structure. Now, all the Pandas commands that are very important are here in this one page. So how do you import Pandas? You import Pandas as PD. Okay. Okay. When you use as PD, it's alias, just like SQL. In SQL also, when you use an as, is an alias, just like that. Even in Python, it's as is alias. So you import it. Then you can pull in a file using read CSV. If you have an Excel file, it's read XSL. You can also read PDF. I think I used PDF. But it was not very successful. The library is not really good, but CSV, Excel libraries are really good. Then when you print in data, you can print the data to get head, gets you the top rows, and this is how many rows you want. If you just give head in most of the Python, it will give you the first 5 lines of code. It limits to 5 by default. And this is like this. I'm saying I want only the 2 of the top 2 function. Top 2 of my data frame. Then you have tail, which gives the bottom 2. When you do the D types, it actually gives you the types of data that's available, the data types of the data that's available. So whether it's an integer, a varchar, a date, timestamp, all those data will be printed out. Index actually gives you the index details. Indexing is actually very important for a data engineer, because if the data is stored in a cloud or anywhere in the cloud or anywhere in the memory, and you don't want it all stored in one, you can actually basically index it. Basically, indexing is nothing but having how do you call it? Having one place where you have, okay, at this address I have this data at this address, so you kind of label it with a particular address, or there are many different types of indexing that you can do. You can have primary key indexing, date indexing. So this way, based on that, for this particular date, maybe it's stored somewhere, very somewhere, you can use that index and you can get that data. So your processor is not processing all the data to find which one you want, but you can, if you index it, you can go directly and pick it up for you and bring it to you. So indexing is very important. Then you can find out if in the column column name state, if the values Karnataka and Tamil Nadu are there. So is a keyword that you can use. Then if you do a df dot columns, it only gives you the columns. If you do values, it gives you the values. Df dot describe describes it for you. I'm just going over the commands, but I'll show you how this code works, okay, for anybody that's looking. Then sorting, it can help you sort the values. Then there's something called slicing, where you can, just as array slicing, you can you can slice the code. You can also slice it with a step. So you want 1 to 3 numbers. Okay, somebody, Anushri, has asked, this could be outside the part discussed today, but I had a small question about how well aware should we know about data pipelines and ETL for data engineer role, and how important is it part of interview? Okay. ETL and data pipelines actually kind of important, but ETL. So for ETL, what is interesting is knowing Python is good enough, because ETL is extract, transform, and load. Anushri. So this is basically how do you extract data, how do you transfer the data and load the data. So when given data to you in a particular format, how do you change it? So change it to what is needed and load it. So if you know SQL and Python together, that can help you with ETL. But yeah, they want to ask you in depth. But also depends on the company. Bigger companies will not ask you in depth, because they'll have an entire different process for data pipelines, but they will ask you questions, but they'll ask data modeling questions, and to see if you know how to model data, and that will help the data pipelines. Maybe for startups, they may ask you more in-depth questions on data pipelines. But the one thing we can do is you can ask the recruiter how the questioning will be, and then then prepare on that particular segment on data pipelines. But just generally knowing what data pipelines is, like how pipelines is, should be good enough. And
I just want to also add, Anju, I think our previous session where you discussed about the ETL data modeling, I think that recording's already up on YouTube. So if Anushri wants to review that content, like it's up there on our YouTube, if you want to like review that content and then post questions for Anju in our Slack channel, because you did go into depth about it. But yeah, it's a great question. Thank you. I guess the another question that came up. Aurelia is asking, let's see. Maybe Anju, you can say like if this was a large question or a small, we can answer it later, but they're asking, could you please briefly explain class and methods inside class and their namespaces? Or is that maybe like a larger question that's beyond the scope of this?
That would be a larger question. That is a larger question. Class and methods, right? Having class and methods, that's actually, but I think the Python series already has one session that has gone into building classes and methods. That's why I didn't bring it up here.
Yeah, we do have in our Woman Who Code Python YouTube channel. We might have it in one of like the series playlists, but they do go into more information on that, on like class methods inside of Python.
So that's a larger question. So
And
going into
Monica's shared the link on the chat. I think like on our there's a Women Who Code Python playlist, and you can like dig in there, and it's like it goes into like the content much more than Anju's scope.
Yeah. This is more because I like I told you in the beginning, Python is huge and a lot we can learn. But if you do have specific questions, please message me on Slack, and we can go over them together. If you have specific questions, I am available on Slack. I have it on my phone, so if notification comes up. So so if you have any questions, please feel free to message me, and we can chat in depth on that, because that's a huge topic in itself. Class methods, namespaces, and actually those are also important as Python. It's not so which actually I wouldn't say it's not important, because in your day-to-day life as a data engineer, you will need to understand namespaces a lot more, because sometimes in a company they'll have different namespaces. And when you have different namespaces, and it also depends on the memory allocation and all that. So they may only give so many terabytes to this namespace and so many terabytes to that namespace and everything. So there's a lot of financial responsibility, processing responsibility, performance behind the scenes with using namespaces. And sometimes when you use multiple namespaces, you may have to bring in the data temporarily from one namespace to another namespace. Some companies have tools. Some companies you may have to do it on your. You may have to find a tool to do it. But when you're working with larger data, it's always better to have a tool to do it, and bring in from another namespace temporarily before you can use it here or use it in your namespace. So there's a lot behind namespace. So if you do have any questions on namespace, please feel free to ping me on Slack, and we can just go in depth on namespace, and I can give you some reading material and everything. Okay, so that's slicing. If you have any other questions, please feel free to continue asking. I know we are a little over time. I'll go up till 6:30. Please don't mind. I do have the questions to go through too. I'll give you the solutions right away, so you don't have to worry too much about that. Then also one thing here in this you should remember is when you do from 1 to 3, right? So this is the start point, this is the stop point, and this is step. So that's how the slicing is. It's like df start, stop, and then step. Okay, for slicing. But if you are doing it, this is the index, right? Index number of that particular value in the array. That's last number or last index is not calculated. So if you are like, for example, you have an array of 1 to 10, and you want only 1 to 5, you should actually slice it from 1 to 6 to get 1 to 5, because that 6, the last stop, is not considered in a slicing. That's something to remember, because I have got caught in this thing. So you should remember that the stop last part is not taken. And then here, this is also a different kind of slicing, in the sense, in a data frame from a particular column you want. So in this, you're saying particular column, literacy column, this is literacy percentage column. You just want all the information about of literacy greater than 90. So from that data frame, it'll take out that. It will filter out that for you, take out only the ones above 90, and then shorten it and give you the shortened data frame. Now, how does this work behind the scenes is from the larger data frame, it will do a filter, it will create a view and create a view in a different space and give you that view. Okay, so it won't do anything to your original data. It will create another view table, and then it'll give you that information. Okay, that's how it does behind the scenes in the address. But your DF will be there in your memory. Your DF will be there when you're printing it. But if you do something like this, right? If you do df equal to, it's coming up here. Okay, please note it's coming up here. And do this. So basically, you're assigning that new table to your df name. It'll alter it. Okay, if you're just doing this, printing the df, it'll create a view and give it to you. But what if you do an assignment operator over here is it'll assign it to the df. So whenever you assign it, you should make sure that if you don't want to change the original data, you give a different name over here. But if you want to, if you're okay changing the original data, you can just do df and make that view the permanent view. That is something to remember. And then you can rename your columns. There are three major functions to remember for data frames: is merge, group by, concat. Okay, and also sort values. Sort values here. Sort values. Okay, so sort values will sort the values. Group by is like a SQL group by. It will group by with whatever you give it here. Group by whichever column names you give it over here. It will group by those columns. Merge will merge the two columns. So by default, merge is an inner join. And then you can specify what kind of join within the merge function, and make left join, right join, and you can also mention which column you want it on there. And then concat is nothing but union. It will concatenate the data. So those are the functions that we got to remember for Pandas. So let's go into some of the questions here. Take time to load. Okay. Okay, so let me. Again, I'm using Scratch, and I'm only using all the free questions available on Scratch, nothing paid. They have 50 free questions when you log in, so that is good. So this is the same as if you have attended my SQL answer workshop. The questions are almost the same from there to here. You can choose which language you want here, so you can do the same thing for SQL. You can do the same thing for Python. And do the question. So you have been asked to find job titles of the highest paid employees. Your output should include highest paid title or multiple titles with the same salaries. Okay. So now you have two tables here. You have the worker table and the title table. So now let's see what is in the worker table, right? See. So this is what I'm going to do is find out. So I'm going to find out what is there in the worker table. Okay, so I get the worker table details by doing the worker.head. So head, so I told you like it gives you 5 by default. So it gave me my first 5 data by default. Now I want to do tail, for example. Do I want to take? So let's do this. Okay, so I want to do tail. So I'll do tail. Tail will also give me the last 5 rows. Okay, so tail gives me the last 5 rows of the thing. So, and then let's see, worker.describe. I don't know if it'll do describe. So it gives me all the description of what is there, what is the worker ID, and all of those information. But since we have all of that information here, so basically, describe will give you all the information like your stats, your mean value, median value, your standard deviation, all of that wonderful stuff. If you want that information, you'll get in describe, But for this answer, what are we going to do? So we have been asked to find the job titles of the highest paid employees. So we need to find the highest paid employees, okay? And we need to have the title displayed. So in one of the tables, worker table, you have the worker ID, first name, last name, salary, joining date and department. In this, joining date department doesn't matter, only salary matters. And over here in the title table, you have the worker reference ID. So worker reference ID will be your foreign key to this worker table. This is how we are going to join the tables to the worker ID and the worker reference ID. Your worker title, and you're affected from from which data, that's not necessary to affect it from. That's a good thing to have. So what we need to do is first, we have to merge these two tables and get all the titles for all the workers. Then we have to find the maximum salary. And that's what I'm doing over here. So I'm using pd.merge and I'm merging the two tables, worker table and the title table. And I'm doing it on left join. I'm doing a left join because why I'm doing a left join is because I want all the workers, even if they have a title or not. I'm just going to take in all the workers. Actually, inner join will also do, but I'm doing a left join. Inner join will take out all the nulls from the right table, but I'm just doing a left join here, which I always do. So I am joining on the left and for the right, I'm doing the worker reference ID. So I'm doing this on worker ID, and here again print out the head. Then over here I'm from this I'm. So if you see here, this is the slicing that I was talking about. Okay, this is the slicing that I was talking about. So first from there, I'm taking out the salary and the maximum salary. Okay, I'm going to merge from the merged information. From the merged information, I'm going to take out all the maximum salaries. No. So I'm taking the maximum salary, or if I take out this and just get my maximum salary, I'll get all the max salaries here. Okay, only the salary information. I'm merging it and I'm only getting the salary information here. Once I get the salary information, I'm finding out if the salary is the maximum salary. That's what I'm doing over here. If DS of salary is equal to the maximum salary. Okay, if it is a maximum salary, then I'm getting the worker title from the data frame. Okay, so that's how I run the code, and I get that assistant manager, the managers, these two have almost the same salaries and they are the highest salaries. Okay. Hope you understood the question. I understood that. I'm doing that. Okay. Everybody's so quiet today. And the next question is, in the Forbes list. Okay, in the next question is the most profitable companies. Find the most profitable companies in the world, output the result along with the corresponding company name, solve the result based on the profits. Okay. Here we use sort values, the function that we talked about. So here I'm making a copy of that DF instead of having to change the my original. I'm going to work on a data frame from here. Then I'm going to sort the values on all the profits. From there, I'm only getting the company and the profit details, and I'm only taking the first three because they've only asked to find the most profitable. So what I'm going to do is sort it, get the top, sort all of the profitable companies, and then only print out the company and profits of the first three. This is very easy, right? It'll just give the first three. Okay. So I hope this is kind of making sense. I hope you've all done these questions, and I hope this is making sense. And then the last one, last question I had was this one. Average session time. This was a very interesting problem to work on. So calculate each user's average session time. So a session is considered when there's a page load and one page exit. There's only one session considered per user at one time. There may be multiple elements in the day. but only we take the latest page load and the earliest page exit. So the maximum load and maximum exit. And so that's what I'm doing over here. So I'm trying to find out only the page load, wherever the page load. I'm first going to work on the page load. Get when the page was loaded, the maximum of the page load. Here I'm going to use a group by function to group by user ID and the day. And here I'm going to use, and then I'm going to get the page exit. Then I'll get df1, df2. I'm going to merge it. And then I'm going to get the mean time over here. Okay, I'm going to get the mean time, which will give me the user ID and their mean times. And that will give me the diff. Those are 3 questions I had. That's all Python I have for today. Does anybody have any other questions? Those are the questions. I can send the question link and also send this presentation so you can work out those questions when you like. So this is sort of the Python cheat sheet we have to do for Python for data engineers. So Eliza,
thank you, Anju. Yeah, this is a great session. Thank you, Anju. I know everyone maybe dropped some like thank you, happy emojis to Anju in the chat for hosting this series and like all the in-depth knowledge, because you've been like doing Python to engineer like questions from like large companies and smaller organizations. So it's like, yeah, we really appreciate sharing your knowledge and like helping give back to the community so they can also land their first role or like, upgrade their role. But yeah. Thank you, Andrew. Yeah, and like you mentioned before, you'll also post, I think, the interview questions in the chat. So yeah. And if folks are like watching the series on YouTube and like questions you can post, I think it's like data science study group in our Slack channel, or like they can like message you. I've been tagging you, I think, on the event update so they can find you in Slack. But yeah, and Monica's doing a great job moderating, sharing all the helpful like links and resources in chat. So thank you so much, Monica. And yeah, I can see some messages. Someone said, Andrew, these classes are like hitting goal for data engineering. Seeing a lot of like heart emojis saying thank you for this fantastic series and a lot of applause emojis. So yeah, Andrew, thank you so much. I know you do a lot and we really appreciate you. So don't burn out. Your day job too, right? So yeah. Yep, an applause and like hearts from Monica. But yeah, Anju, I guess we'll wrap up the session and like other further links. We'll share them Slack. Maybe we'll share them on our GitHub too.
Yeah.
Anju. And like you said, we'll have like articles coming out either on our Women Who Code Python Medium blog or on the global Women Who Code Medium blog. They'll be coming out, and I'll try to share the links like also in our Slack when the columns team decides to get published. But yeah, so thank you everyone for joining us of the series. Thank you, Andrew, so much for spearheading and creating all this content and just like, just like being a regular like hero going through like, overcoming colds and bad weathers, and now it's like hot weather. So it's like everything, but yeah, you tackled it and like succeeded. So we're really proud of you and thank you so much. Yeah. All right then. So
thank you.
You're welcome.
If anybody has any questions, please contact me in Slack and I'll be happy to help. And we can solve problems together.
Yeah. It's always a new problem to solve, but yeah. All right, so I'll wrap up saying good morning, good afternoon, good evening to everyone where you are. I hope you have a great rest of the week. Okay, bye-bye.